We're going to continue to look at classes today, and in particular our coordinate class. Now, so far we've just used it for storing data, but actually classes can do quite a lot more than that. We can add additional functionality. So if we take, for example, our coordinate class, it'd be really handy if we could know, for example, if one coordinate was further north than another. Okay, so we can actually add methods that provide this functionality. So let's go ahead and do that now. So for something to be more north, all it's got to do is have a higher latitude value than another one. In order to know what we're comparing it with, that method that is going to find out whether it's more north of another one will actually need a parameter that is also a coordinate. So we can say we'll create a public boolean, because it's going to return true or false. We're going to say is north of, and we're interested in whether or not it's north of another coordinate. So we could say north of coordinate other coordinate. Okay, and the logic for that is pretty simple. It's basically if this one, so we can do this dot latitude is greater than the latitude of the other coordinate. Okay, now because this is also a coordinate, it does allow us to access the latitude, even though it's private. We'll actually use the get latitude just for sort of cleanliness. Similarly, we might want to make it easier rather than users having to negate that, and actually the opposite of is north of is not is south of is not necessarily just an inversion of that particular test, because in theory two places could share the exact same latitude. So just for convenience, we'll also create a is south of, and that will just return whether or not this latitude is less than the other coordinates latitude. Okay, so we've got two methods there. We can actually see that in use. If we go back to our main class, okay, we might want to check if Chester is north of London. For those of you who don't live in the UK, Chester is north of London, so that might help us check whether they've got the expected output. So we can now do something like this. We can say if, and then we could say if the Chester coordinate is north of the London coordinate, then we can print out Chester is north of London, else Chester is not north of London. Just to verify that works, we can run it and view the output, and there, yes, we can see that Chester is north of London. I've left the original print statements in there, so we'll remove those as well. Okay, so we've added some additional functionality. We don't necessarily have to leave it there. Okay, some of you may know that coordinates are not necessarily only represented in a decimal format. We can also represent them as degrees, minutes and seconds. Now what we're currently doing when we do get latitude is getting a decimal representation of the number of degrees. Okay, we can amend that. Well, not amend it, we can add additional functionality that allows us to get, for example, the degrees, the minutes and the seconds for both the latitude and longitude. So let's start by doing that. Now when we do degrees, minutes and seconds, we return the degrees and the minutes as integer values, and then the seconds, in order to get that additional precision, we'll often do as a decimal, so we use a double for that. So we'll start with our latitude, so we'll do public int get latitude degrees. Okay, that's relatively simple because it is just the double value minus any decimal point. So provided we cast the decimal value, so the double value to an integer, we'll get that result. Okay, just verify that. Quickly go back to the main class and just print out the Chester coordinates dot, and we'll get the latitude degrees. We know latitude is 53.1, so we should see a value of 53 printed out. And we'll get rid of this just for now. There we go, so that's working okay. We can return to our coordinate and we can implement the logic for the minutes and seconds. Okay, it's a little bit more complicated. First of all, we need to work out what the minutes are. Now, the minutes are not including the degrees, so we're not going to sort of multiply the degrees by 60. We're going to remove the value for degrees and just get the minutes component. So we can create a variable for that, and then we want to get our latitude, and we want to take away this latitude degrees value, which is the integer version. Okay, that gives us the remainder. So if it was 53.57, it would be 0.57. We want to convert that into minutes. Well, obviously there's 60 minutes in a degree, so we can multiply that by 60. And then we want to return that as an integer, because it will still have decimal points that represent the seconds or even the fractional seconds. So we can convert that to an integer and return it. Okay. Same process applies for the seconds, except that we're going to return the seconds as a double because there will also be a decimal point on that. So we can say public double get latitude seconds. Okay, in order to do that, we still want the minutes value, okay, because we can't just call this because it will get us the integer. So we'll do our minutes. That gets us the decimal minutes with the decimal point. We'll then remove the minutes, so we can say something like double seconds equals our minutes minus, and if we do the get latitude minutes, that gets us the integer component. So that gives, now we're now left with the remainder. There's 60 seconds in a minute, so we can multiply that by 60. Now, at this point, we could return seconds because it's a double. We don't need to convert it to an integer like we did before. So actually, rather than saying double seconds equals, we'll just simplify that and write return. So we can then go back and test those. So we were doing the latitude degrees. We'll do another one. We'll do the latitude minutes, which gives an integer value, and then the seconds, which should get us a double value. So let's just run that now. There we go. So we can see that Chester should be at 51 degrees, 11 minutes, and 36.2 seconds. Okay. The other thing we can do, as I mentioned in the previous tutorial, is we can put these coordinates into a list. So we might, for example, have an array list of coordinates, coordinates visited, and we'll take a collection of all the coordinates we've been to, and that's going to be a new array list of coordinates. And we might add, say, Chester's coordinates, and London's coordinates to that. Like any list, we can iterate through it. So we can create a for each loop. So we can say for each coordinate, we'll call it coordinate in coordinates visited. And what we might like to do is just to see all those coordinates. Now we can try and do that. We've got to remember that coordinate is an object, i.e. it's an instance of the class we created. I'll just comment out or remove these earlier print statements. So we should just see a printout of the coordinate. It's interesting to see what happens here. Okay, we've got two outputs. We've got the name of the class and some other value here. Okay, well that's not terribly helpful. Okay, what would be more useful is if we actually saw the latitude and longitude printed out. Okay, now what is not immediately obvious is that our class is actually in Java extends something called object. So any class we create in Java is actually and has all the features of a pre-existing class called object. Now normally when we do what's called inheritance, where we inherit from another class, we make that explicit by writing, for example, extends and then object. But this is implicit in Java, so we could leave that there, but it is essentially already there even though it's not stated. And you might think, well, when we've tried to print it, how does it know what to print? Okay, because there's no sort of print output or even anything that returns a string here. Okay, so what happens is actually, if we were to put that extends object back in, and if we were to look at that object class, we would find out that there is actually a toString method buried in here. Got methods to check whether things are equal. Here we go, toString. Okay, and that actually returns the name of the class plus its hash code, and we could look up here and find out what the hash code is if we wanted to. So that's why we're getting this printout value here. Okay, we can actually override that and provide a different printout. Okay, so if we start writing toString and hit enter, it will actually create a method called toString that returns a string. It's also annotating it in its particular IDE as actually overriding a method, which is helpful because it means that we know that this method actually is declared in that object parent class. And it currently just returns what happens if we call the toString method in object. Well, actually that's not what I want. What I wanted to do is to return a nicely formatted representation of my latitude and longitude. So I'm going to change that so it prints out the latitude and the longitude. Okay, so now if I go back to my main method where I actually try and print all of the coordinates and run the logic again, it will implicitly call toString and we'll see the latitude and longitude values printed out. So that demonstrates how we can add additional functionality. Obviously this class is not complete. We might argue that, for example, we need methods for getting the longitude, degrees, minutes and seconds. We might even go as far as working out how far apart two coordinates are. So we can have a method that says distance between this coordinate and some other coordinate, and work out the logic to get an approximation of that distance. If you want the challenge, that's something you can do.